Hello, my name is Jessa, and today I help to unravel the cheMYSTERY of the periodic table.
Back in the 19th century, there was this guy named Dmitri Mendeleev who saw that at the heart of the universe were these basic building blocks, what we now call elements. He noticed that there were a tremendous number of substances with different characteristics, causing them to behave in wildly different ways. He also noticed that the properties of elements were almost always directly related to their relative atomic mass. He used the atomic masses of these elements to arrange them into a table. This system was so accurate that Mendeleev knew to switch some elements and leave gaps for undiscovered elements based on these patterns. Later on, a physicist named Henry Moseley arranged the table by atomic number, or the number of protons an atom had, rather than atomic mass, which made the table follow these patterns even more seamlessly. This is because it is not the mass of an element that affects its chemical properties, but the number of protons that it has. The periodic table we know and love today is organized into rows and columns. The rows are called periods, which is where the name periodic table comes from, and the columns are called groups or families. Elements in the same group have similar chemical properties because they each have the same number of valence electrons. Valence electrons are the electrons in an atom's outer shell which are available to form bonds. The most stable an element can be is when it has a full shell or 8 valence electrons, and the most reactive it can be is when it has only a single valence electron. But why is all of this so important? The periodic table can be used to predict properties of elements, even those that have not even been discovered yet. Additionally, the table makes trends in element properties apparent, and understanding the properties shows how and why reactions take place. Overall, the periodic table is the most powerful scientific resource that we have. Consider element number 64, gadolinium. Gadolinium is in the middle of the rare earth row and has the maximum number of electrons by themselves in orbitals. Having so many unpaired electrons allows gadolinium to be magnetized more strongly than any other element. This property allows it to be easily detected on an MRI machine. So, when doctors are trying to diagnose tumors, they can use this bit of knowledge from the periodic table to use tumor-targeting chemicals in conjunction with the magnetic gadolinium to effectively detect tumors using magnetic resonance imaging techniques. Additionally, carbon, element 6, is in group 14, which means it has 4 valence electrons and can thus form 4 bonds with other elements. This tetravalency gives carbon the unique ability to build straight chain, branch chain, or ring molecules. These structures are found as functional units in organic macromolecules like proteins and lipids, which are necessary for life. From curing cancer to supporting life, the positioning of each element on the periodic table reveals its unique destiny. The periodic table is constantly growing and changing to reflect advances in scientific discovery and to propel those advancements forward.